For hundreds of thousands of years, humanity has lived beneath a familiar sky, one shaped by gentle air, a warming sun, and the protective cradle of Earth's atmosphere. Here we learn to grow food, build cities, and imagine worlds beyond our own. But as our species expands and our technologies advance, Earth begins to feel less like the only possible home and more like the first chapter of a much larger story. Beyond our blue horizon stretches a vast expanse of planets, moons, and empty space, environments hostile, unforgiving, and alien. Yet within these same environments lie opportunities, new frontiers where human ingenuity might carve out settlements, where fragile habitats might bloom like islands in a cosmic sea, and where the future of our civilization could unfold far beyond the place where it began. The dream of living off Earth is no longer confined to science fiction. It is a plan, a blueprint, a destination. Our species stands at the threshold of a new era, one where humanity begins building homes in worlds that once seemed unreachable. The first step beyond Earth lies just 380,000 kilometers away. The Moon, our constant companion. Its barren surface, untouched for billions of years, offers no atmosphere, no protection, no warmth. And yet, beneath its harsh exterior, the Moon holds immense promise. In the shadows of its polar craters lie vast reserves of frozen water. Ice that can be melted into drinking water, split into oxygen for breathing, or transformed into hydrogen fuel. This resource alone transforms the Moon from a lifeless rock into a possible launch pad for human exploration. Future habitats here may take the form of lava tube settlements, built deep beneath ancient volcanic channels, shielded from radiation by tons of rock. Other habitats could be inflatable domes, 3D, printed with lunar regolith, illuminated by artificial suns suspended above gardens of carefully engineered crops. The Moon will not be comfortable. It will not be easy, but it will be possible. And that makes it the natural first home for humanity beyond Earth. Farther away, orbiting in the chill of the inner solar system, lies a world that has captivated human imagination for generations: Mars. Its skies are tinted orange. Its mountains dwarf those on Earth. And though its air is thin and its winters unforgiving, Mars offers something no other world has: a landscape that feels almost familiar. Mars has water ice locked beneath its soil. It has days similar in length to ours. It has resources that can be mined, processed, and reused. On this planet, humanity may one day build entire settlements, sprawling across crater rims and canyon floors. Future Martian habitats might include underground colonies, shielded from radiation by meters of soil. Glass-domed greenhouses could glow like lanterns in the Martian dusk, sustaining crops that feed explorers and settlers alike. Entire cities may grow inside excavated cliffs or within pressurized corridors stretching across the red plains. Life here will be harsh. The thin atmosphere offers little protection from cosmic rays. Dust storms can blanket the planet for months. Every breath, every drink, every step outside the habitat will rely on technology working perfectly. Yet for all its challenges, Mars may become the first world where humanity lives not as visitors, but as permanent residents. Not all future homes will rest on the surface of a planet. Some will drift in the void itself, suspended between worlds. Humanity may build orbital habitats, vast rotating cylinders, rings, and spheres designed to simulate gravity through motion. These artificial worlds could be engineered with Earth-like environments inside them. Sunlight simulated through mirrors, weather controlled through atmospheric systems, lakes and farmland stretching along interior surfaces. In such habitats, people may live miles above the vacuum of space, surrounded by metal walls, but experiencing the comfort of Earth-like gravity and climate. These are not distant fantasies. They are plausible extensions of technologies we are developing today: life support systems, closed-loop ecosystems, radiation shielding, and advanced manufacturing methods. Space habitats offer flexibility no planet can: perfect lighting, controlled seasons, artificial gravity, and expansion without limits. They represent a future where humanity is not bound to the surfaces of worlds, but instead creates its own worlds. A civilization of orbital habitats could one day spread across the solar system, connected by networks of stations, farms, factories, and shipping lanes. Beyond Mars lies a realm colder, darker, and far more mysterious. A region where sunlight fades and the giant planets rule. Here, moons become the new frontier. On Europa, subsurface oceans may harbor the building blocks of life. On Enceladus, geysers of water erupt from deep beneath icy crusts. Titan, with its thick atmosphere and methane lakes, offers a world more alien than any imagined in fiction, yet surprisingly hospitable to human engineering. Habitats here might float above Titan's lakes or burrow beneath Europa's ice. Nuclear reactors could power insulated bases in lands where the sun provides little warmth. Crews stationed on these distant moons would be explorers in environments never meant for human survival. Yet their discoveries could reshape our understanding of life, biology, and the solar system itself. The outer worlds are harsh, but rich in resources: water, metals, hydrocarbons, and raw materials that could sustain entire colonies. Humanity's presence here would be the ultimate expression of resilience. Life thriving in places where life should not exist. Far beyond our sun lies a vast tapestry of stars, each with its own worlds, its own potential homes. Reaching them will take more than rockets. It will require generation ships, immense traveling habitats where entire communities live, grow, and evolve over centuries. Inside these ships, ecosystems may be crafted with precision: forests, rivers, gardens, and cities enclosed in giant rotating hulls. Each generation born aboard will inherit responsibilities, learning to maintain their miniature world as it glides through interstellar space toward a destination they may never see. These vessels will be humanity's most ambitious habitats, self-contained, self-sustaining, bound not to a planet but to the journey itself. In the distant future, they may carry humanity to exoplanets orbiting distant suns, worlds that could become the next Earth, where new civilizations break ground under unfamiliar stars. The future of human habitats beyond Earth is not a single place. It is a spectrum of worlds: the moon's silent plains, the red deserts of Mars, the drifting hulls of orbital stations, the frozen oceans of distant moons, and the vast interstellar arcs that carry our descendants to new suns. Each habitat will demand creativity, perseverance, and a willingness to face environments that challenge every aspect of human life. But each will also offer something Earth cannot: new beginnings, new opportunities, new chapters in the story of our species. Humanity was born on Earth, but we were never meant to remain here forever. The cosmos is too vast, too rich, too filled with possibility.